Alrighty, we are live, and sorry I got started just a couple minutes late. Apologize for that. Today we're doing the classic candle in a jar, or I'm calling it the candle in a glass experiment. It's a pretty well-known experiment. I hope that I can enlighten you as to what's going on. You're going to need a candle, some matches, water, a glass or a jar. You want it to be a glass too. Don't want to use plastic, okay? So want transparent glass or jar. And then you're going to need like a plate or a bowl. All right. One more time. You'll need a candle. You'll need some matches, water, a glass, transparent glass or jar, and a plate or a bowl. And we will get started in about a minute and a half. Get started about a minute and a half. And yeah, so that's what you'll need. All right, I see Ashley Randolph. Thanks for joining us today. Yeah, I see some people there on Instagram. Good to see you. All right, so I'm trying to deal with my lighting here. I got let me one more time just say what you need. We're doing a candle in a glass experiment. You'll need candles, matches, water, a glass or a jar. Make sure it's transparent. Make sure it is glass, not plastic. And then you'll need a plate or a bowl. And I'm going to turn on the light. Different light. All right. Okay. So welcome back. This is week 5. Can you believe it's been 5 weeks? And my name is Dr. Boyd, the chemist, and I work at the Naval Research Lab in Washington, D.C. I am teleworking, so I'm doing this during my break. And I am a research chemist, definitely a research chemist, and I've been working at the Naval Research Lab for several years. But in my free time, I do things like this, which is science for outreach purposes. And most of the time I work with children. The lessons that I'm teaching are geared towards children who are in kindergarten all the way up through about 5th grade. So you're talking 5 years old roughly to about 11 years old. And I hope you get something out of these lessons. If you want to see some of the lessons that came in the prior weeks, you can go to my YouTube channel. And I've posted the first 4 weeks all there on the YouTube channel. You can find my YouTube channel by going to YouTube and searching for Dr. Boyd, the chemist. Subscribe and you'll get all the updates on when I have new posts. And I typically I'm posting every week. And so I'm hoping that you subscribe, tell a friend, and I'm hoping that People are learning from everything. Also, if you want to follow me on Instagram, I post there as well. Follow me on science-made-simple_LLC. I just opened that Instagram page when we started doing these lessons. And so definitely subscribe to that for further information there as well. Today, we will be using matches and a candle. And so that should ring a bell immediately. If you've been following along the last several weeks, I've talked consistently about one very important feature of doing research, and that is safety. And every time I do an experiment, whenever I run a reaction, safety is the most critical, most important aspect of the work that I do. So I want you to know, anytime you do an experiment, you always want to be concerned about how can I do this experiment safely? All right. Now, we are using flame or fire today, and so I will be wearing safety glasses. Make sure your parents are handling the matches and the candle, okay? Again, make sure your parents or an adult is handling the candles and the matches, okay? I don't want anyone to get harmed or to be hurt. I will be putting on my lab coat. Now, I will tell you, this is kind of like lighting a candle on a birthday cake, so you do not need the safety glasses and you do not need a lab coat, but being the scientist that I am, I'm just going to take that precaution. I'll put some safety glasses on and I'll put my lab coat on. And then I'll light my candle at that point. But what are you supposed to bring along with you when you do an experiment? It's the 5th week, so you ought to know. Good old lab notebook, something to write on and something to write with, okay? I will just tell you something very important. If you're a professional scientist, you work in a lab, we typically do not write in pencil. We write in pen because the integrity of your notebook is so important. We don't want people erasing things from their notebook because sometimes people may find something out and they'll erase it. And that's not very good lab practice. We typically write in pen. We write in pen. If we make a mistake, we just put one mark through it to cross it out like a strike through. And that way we know what we had written before. It's good for reference purposes as well that you don't erase everything, because sometimes you might have erased something that you later on realize you should not have erased. All right. That's just a side note on writing in your lab notebook. So today, write down the topic. The topic is candle in a glass. Write that down. And also write down what you need. Now, we should have done that already. Everything that you need for the experiment. Today, I'm going to take this candle and I'm going to light it and I'm going to place it in the center of this plate. I'm then going to pour water around the base of the candle. All right. Once I do that, I'm going to take a match, light the match, and then light the candle with the burning flame there. Then I'm going to take this empty glass, and again, if you have a jar, that works too, and make sure it is glass because we're dealing with a flame. Plastic will melt. This glass is not going to melt, not at these temperatures at least. All right. I'm going to place the glass over the top of the candle, and then I'm going to observe what happens. All right. So before we do that, let's have a discussion on what this candle is experiencing right now. What is happening with this candle right now? What does it feel? All right. This candle feels the same thing that you feel. It feels the air, it feels the atmosphere. Now, believe it or not, every day when you're walking around, especially if you walk outside, there's this stuff happening to you, you don't even think about it. There's pressure on your head. All right? There's pressure on your head. You're holding like a mile of pressure just on top of your head, and you didn't even realize it. I'm inside now, and so this candle is not experiencing thousands and thousands of feet of pressure on its head like maybe outside, but it is experiencing pressure down, or air, I should say, air on it. Now, we are all experiencing pressure inside and outside, and presumably it's roughly the same inside and outside. But the air, there's not a column of air from the sky all the way down on this candle, but it's experiencing roughly the same kind of air on top of it that I'm experiencing on my body. We don't think about it, but that is what is occurring. It is also experiencing the wind current, the air current. The air that I'm breathing is experiencing that as well. What happens when I take this glass and place it over the top of the candle? Is the candle now still experiencing the same things that I'm experiencing? Is it different? All right. If the answer is yes, it is experiencing the same thing that I'm experiencing now, what would cause it to experience something different? And I'm specifically talking about pressure, okay? As well as temperature, all right? Now, in chemistry, there are a number of laws that dictate, that are related, I should say, there are a number of laws that are directly affected by temperature and pressure. There are a number of gas laws specifically that are related to temperature and pressure. The one that actually made it into the news a few years ago when there was controversy over the deflating of NFL footballs by the New England Patriots, Deflategate they call it, and I chuckled when I heard the coach of the Patriots, Bill Belichick. He started talking about the ideal gas law. And some of the things he said, there was actually scientific credence to what he was saying. And yes, the deflating the balls will have an effect on how the ball travels through the air, believe it or not. So the ideal gas law, it has these letters. We say PV equals nRT or PIV NERT. But the P stands for pressure. The T stands for temperature. I'll actually write it down so you can see how we write it in the laboratory or in our notebooks. All right. Sometimes we call it PIV NERT. PV equals nRT. That's pressure times volume equals the number of moles times this constant R times temperature. Now, whenever you see an equal sign in between, you're talking about a mathematical relationship. What I see over here is this T and this P are in a direct relationship as opposed to an inverse relationship. If it was inverse, there would be divided by something on one of the two sides of the equation. But no, the P is in a direct relationship with T, all right? Pressure is in a direct relationship with temperature, all right? I just wanted to point that out because what we're going to do today highlights the importance of pressure and temperature, okay? Without getting into a long discussion on what all the rest of that means, PV equals nRT, and trust me, you spend lots and lots and lots and lots of time as a chemist dealing with that, particularly in the education and academic phases of doing chemistry. So we spend a lot of time on PV equals nRT. But if I alter something on the inside of this container, I can alter the pressure, all right? What might that be? Ah, yes. If I alter the temperature inside this container, I can alter the pressure, meaning the pressure being experienced on the inside of this container by the candle will be different than the pressure I'm experiencing on the outside of the candle. All right? So let's go ahead and do this experiment, and then afterwards we'll have a brief discussion. First thing you want to do is get some water. So I have my candle on a plate, and if you have a little small candle, maybe you might want to get something sticky or gummy like some putty and place your candle directly in the center of it. My candle is pretty flat on the bottom and fairly sturdy, so I know that it won't tip over when I do this. Now, I'm going to take some water, pour it in here. Now, not too high, but I do want to really be able to see the water. So what I'm going to do is I'm going to dye my water. You don't have to do this, but for visual purposes, I hope I'm able to show you that something is going to happen to the water. All right, so my fancy stir bar here. These things come in very handy. All right. And before I go any further, I am going to suit up here, put my safety glasses on. Don't laugh at my strawberry shortcake sticker. You thought I was going to wear a white lab coat, didn't you? My fancy blue lab coat that I got from the Chemical and Engineering News journal. They gave this to me when I won an award, and I thanked them for it. It's really nice. I do not take this to my job. I use this one for demonstrations when I work at schools or when I'm running reactions for my YouTube channel. All right, so I'm all suited up here, and I am now ready. Again, you may recall I said that a lot of lab coats, most lab coats impart flame retardants. They're flame retardants. So I have some protection from a burning flame, and that is why I am wearing this today, because I'm using a flame. All right, so what I'm going to do next is I'm going to take water and pour it in this container here on this plate around the base of the candle. All right. And again, you can use a bowl. I'm using a plate, and I kind of feel like I need a little more water. And I know here on Facebook, you might not be able to see so well, but that's what it looks like. All right. Make sure my folks on Instagram can see. All right, good. I'm going to actually get a little more water, so bear with me for just a moment. All right. I feel like I keep the food coloring companies in business. I have a lot of it. Okay, so that should be good. All right. Again, for all the children, I want you, all the students, I want you to be careful with the matches. And in fact, I really would prefer if the adults that you're doing this along with will handle the matches and not you. And adults, you be careful as well. So I am going to light this candle. All right, I'm gonna put that in my extra water. So the candle's burning pretty well, right? Now, what I want you to really pay attention to is when I put this on top, I want you to look at the water level, and I want you to look at the behavior of the candle. All right, so here we go. 1, 2, 3. All right, so my candle went out, and it's a little hard to see probably from your perspective, but what happened was on the inside of the container, the water level rose. All right. Why? Why does that happen? Okay, a couple things occurred. The candle went out. Let's answer that question first. Why did the candle go out? Why did it burn out? All right, well, I can tell you, candles burn, the flame burns, fires burn because they have some kind of fuel. They have a fuel, okay? What is the fuel? Well, oxygen fuels the burning of the flame. So as long as there's oxygen, then what you'll see is the flame will continue burning. All right, once you remove oxygen, then the flame will go out. All right, inside this container, there was oxygen present, just like there's oxygen present in the air that I'm breathing. But as that flame keeps burning and now it's been blocked off to more sources of oxygen, it eats up all the oxygen, and ultimately the flame can't survive in that condition. All right. But why does the water go inside? Why does the water fill up? Why does that happen? Well, write down what you think, and then we'll talk about it. Okay. Hopefully you wrote down an answer. By the way, that will be your hypothesis. And as you know, a hypothesis is an idea or a prediction or a guess that you can test. All right. So we've gone through the testing part. Well, maybe we haven't quite tested it, I suppose. We could do more to actually answer that question. But let me just say the pressure on the inside of the container is different than the pressure on the outside once I have that flame inside of the jar or the glass. When the flame is inside, it is heating up all the molecules in the atmosphere on the inside of the container. Okay, it's heating them all up. Then, once the oxygen is depleted and the flame dies and goes out, all those molecules cool down rapidly. They cool down very fast. They cool down, in fact, fast enough that the pressure on the inside of the container decreases rapidly. So now on the inside, I have low pressure, but the air outside has stayed roughly the same, meaning relative to the air inside is high pressure. So there's high pressure outside of the container and low pressure inside. When that happens, the water rushes into the inside of the container because there was an imbalance in pressure. It goes from the water goes from the high pressure area that forces it down into the low pressure area that's not forcing it down as much. All right. So there are two processes happening. The depletion of oxygen causes the flame to go out, but the rapid cooling of the molecules inside the container caused the water to rush in as a result of low pressure inside and high pressure outside of the container. Oh, there goes my water. Okay. So there are a couple things that you could try to further demonstrate that, in fact, the pressure and the temperature are really the reasons why the water rushes in, rushes out. You could try putting soap in your water. All right. If you put soap in the water, what do you think will happen? Okay. You might see bubbles. Why would you see bubbles? Well, you'll see bubbles because the water is moving as a result of the pressure or the imbalance in pressure on the outside and on the inside of the container. All right. So let's just do a brief review. I mentioned this equation. I'll actually write down what it's called. It's called the ideal gas law. And again, if there's a little budding scientist out there, you will deal with this as a chemist, at least, a lot. And you'll also, in physics, you'll deal with this as well. The ideal gas law states that PV equals nRT, or pressure times volume equals N, which is your number of moles, that's MOLES, times R, which is a constant, times T, which is temperature. All right. And I don't fully explain that today, but perhaps I'll explain it in one of these lessons later on, what PV equals nRT is, and we can do some other experiments and we can deal with some of the other laws that are encapsulated in that ideal gas law, like Boyle's law or Charles' law. In chemistry, we learn lots of laws. So pressure is directly related to temperature. Pressure is directly related to temperature. It's also, you'll notice temperature and volume are also directly related. Okay, so pressure and temperature have a direct relationship. What happens when you put the jar over the candle? What happened to the actual flame? It burns out. Why does it burn out? It burns out because it no longer has fuel. It has no more oxygen to fuel it. Okay, what happens to the water when the flame goes out? The water rushes into the container. Why does the water rush into the container? It rushes in because there's low pressure on the inside of the container and high pressure on the outside. Therefore, the high pressure forces the water into the container. What caused the low pressure on the inside of the container? What made it low pressure? It became low pressure because when the flame was burning, it was heating all the molecules inside the container. When the flame went out, those molecules cooled down rapidly. When they cooled down, that's temperature, the pressure also went down. Remember, they're in a direct relationship. So a decrease in pressure is a decrease in temperature inside the container. Or put another way, a decrease in temperature will cause a decrease in pressure. All right. So that is our experiment for today. I hope you enjoyed it. I'll post what we're doing tomorrow. Again, I have some ideas on what we can do, trying to stretch this out as long as possible. Of course, I'm pretty much stuck at home like everyone else, so I have limited resources, but I'm hoping that you all are gaining something from these experiments, and I'm looking toward doing this for as long as I can. And if you missed any experiments, they are posted on my YouTube channel. Again, you can find my YouTube channel by searching for Dr. Boyd, the Chemist. I posted last week's experiments this morning. So all 5 of them from last week are posted as of now. And the first 3 weeks are also posted. Once you go to my YouTube channel, just look for playlists or look for videos. But if you look for playlists, I have them in 4 different playlists, week 1, 2, 3, and 4, listed as homeschool science lessons. All right, homeschool science lessons, week 1, homeschool science lessons, week 2, and so on. And so they're posted there. Definitely subscribe to the channel. Let people know I'm doing these, so people might as well come and join us. And I hope you enjoyed the show today. So I will see you tomorrow at 2 p.m. Eastern time. All right, take care.